So, if we are looking at lesson 6.3, I'm calling this part B because it would have been Friday, we looked at just an introduction to this lesson. And on Friday, what we looked at was if we had a number like 27 to the 1/3, we looked at how we take this 1/3 and how we can rewrite it as the cube root of 27, and how what we are trying to do here is find out what number can we multiply together 3 times and get 27. Remember, it has to be the same number every time. In this case, the answer would be 3, just a single number 3 would be our answer. So today we're going to look at finding the nth root, which really just means instead of having just 27 to the 1/3, maybe we'll look at we will look at a number that's like maybe 108 to the 2/3, where this numerator, so far it's always been 1 for us, but what happens if it's 2 or 3 or 4 or a different fraction? So as an introduction, finding the nth root, this is more of a vocabulary thing. Right here's what the book says when finding the nth root. What we need to get out of that is how we talk about these. So we would say that this is the 3rd root of 64. We would say that this is the 4th root of 108. Sometimes you might hear me say this is the cube root of 64. When we have something like this, technically there's an imaginary 2 here. That's why we call it the square root. We never really write that 2, and we just call it the square root. The next with a 3, that would be the cube root. But then once we get into these numbers like 4, 5, 6, that would be the 4th root of 108, or the 6th root of 216. So that's just a little bit of language there. Now, if you looked at the extension on, I think it must have been 6.1, you might have seen some vocabulary that had to do with rational numbers. We didn't spend a lot of time on that. But all a rational number is some type of any number that can be written in fraction form. So like 1/2 or 3/4 or 1/3. But that also includes whole numbers, because whole numbers can be written as 1/1, 2/1, etc., and could still be written in fraction form. What is not included would be a number like pi or like the square root of 2, because those go on forever and ever and ever. So when we say that we want a rational exponent, that's just saying we want our exponent to be able to be represented in fraction form. Now this is what we've looked at so far, like I talked about in the beginning. We might have a number, and then it's to a exponent, that's a fraction, and we've always had 1 as our numerator, and we've been able to write it like this. Now today, and I really want to focus on this part of the diagram and this part of the diagram. Today we're going to rewrite it, or we're going to look at these and rewrite them when we have a number up here. This m value is not always 1. So as you can see, I've written a couple examples up here. But if we have something like 8 to the 2/3, we could rewrite that as the cubed root of 8 squared. That's how we could rewrite that. On the other hand, if we had the cubed root of 64, we could rewrite that. Whoops, that's not what I wanted. If we had the cubed root, let's say of 4 to the 5th, we could rewrite that and bring this 3 underneath the 5, and it would be 4 to the 5/3. So that's a quick couple of examples of how we can rewrite these. We're going to look at one more example of how we can further develop the rewriting of those rational exponents. So a few examples. What the directions might say with problems like this is write the expression in rational exponent form. So it's not even saying to solve, just write it in its other form. This first one is what we've been looking at already. When there's no exponent here, we know that it's just to the first power, or to the 1. So we can rewrite this as 5 to the 1/7. Here we're taking this 8, putting it under 3, so 6 to the 3/8. Now in this case, first we need to look at rewriting this cubed root of 4, because these parentheses mean we need to deal with that first. So this would be 4 to the 1/3 power squared. Now with our exponent rules that we looked at earlier last week, we know that we would multiply these two. So that would give us 4 to the 2/3 would be how we rewrite that. So that's one set of directions you might see. Write the expression in a rational exponent form. Another direction you might see, write the expression in a radical form, so the opposite. So radical form, we need our square root involved. So now we're just taking this 5 and putting it on the outside of the square root. So our 5 comes here, and we just have 78 squared. Pretty straightforward. Now this is where things get a little more interesting. Simplify the expression. Now what we want to do when we're simplifying is we want to first rewrite this expression so that our exponent has a 1 as the numerator. And we can do that. We keep our base, we can keep our denominator, but we can pull this 3 out here. Because if we look at our rules with our exponents, 16 to the 1/4, and if we simplify 2 to the 3rd power, it's our power to a power rule, we are multiplying these. So it would be 16 to the 3/4, which is exactly what we started with. So when we're simplifying this, we can find 16 to the 1/4, because that's what we practice all day on Friday. We want to figure out what number can we multiply by itself 4 times to get 16. And we will find that that is 2. Now 2 to the 3rd, that will give us 2 times 2 is 4, times 2 is 8. So our goal in rewriting these is to try to get it into this form, where we have 1 as the numerator, because we can simplify that. We've practiced that, that's no big deal. Now, if we have 9 to the 5/2, I want to look at this because we also might have some that are in radical form, where it's like this, 9 to the 5th, and then we need to square root it. With a lot of these, what we want to look at doing is, even when it's in the square root form, if we can simplify, then take the square root, that's pretty easy. Square roots are good. But if we have something like a 3 or a 4 or a 5 or some other number here instead of 2, then it's really difficult to take the cube root, the 4th root, or the 5th root of a number inside this root bar. Especially something like 9 to the 5th would be a huge number to try to take the 4th root of, or the 5th root of. So what we want to do is write this in exponent form here, and then we can rewrite it again, pulling that numerator out on top. And again, we can do that because of the power to a power rule that we talked about in the first one. So when we're simplifying now, we can do this pretty easily, because 9 to the 1/2 is the same, something to the 1/2 is the same as square rooting it. So square root of 9 is 3, and to the 5th power, I believe that is 216. So again, our goal, we need to get it into the form where it's our number to the exponent that has the 1 as its numerator right here. And we can rewrite these using our power of a power rule. Now, the last type of problem that you'll see that I want to quickly cover is these volume problems. So we know that volume equals side times side times side. So when we have a cube, we multiply each side together to get the volume. Another way to say that would be to find sides cubed. In this problem, they give us what the volume is. They say it is 216. Oh, this isn't 216. This is 240 something. That's where I got the 216 from. I was thinking ahead. But they tell us that is 216. So we know 216 equals sides cubed. Now to get rid of this cube, we want to take the cube root, because remember, we're trying to solve for this s value so we can find out what one of these, or what each of these sides are. So to get rid of this cube, we take the cube root of each side. And the cube root of 216 we would find is 6. Now this makes sense because in algebra we're used to seeing something like this. 9 equals x squared. And we say, all right, how do we get rid of this square in the exponent? Well, we take the square root of each side. We see that x equals 3. We're applying the same idea. Instead of taking the square root, though, we're taking the cube root right here. Taking the cube root to each side. And we can find that each side has a value of 6. So in these volume problems, most of the time when we're doing them, the number that they give us, we're setting equal to our sides cubed and going to be looking for the cube root. Not every single time, but most of the time that's what they're looking for. So I think we forgot to look at our learning target in the beginning. Students will be able to write and evaluate the nth root of a number. All that's talking about is if we have a number maybe to the 4th root or a number to the 5th root. This number right here we refer to as the nth root. And that's what we just looked at. So if you have any questions, make sure you send me an email. Otherwise, have a good rest of your day.